This is our Gate 4.5 presentation. We're Team 2, designing the hybrid asparagus harvesting robot.
So for our project description, we want to design a fully or semi-autonomous asparagus harvesting robot that will utilize computer vision and other sensor technologies to do the following, which is localize asparagus stalks in 3D space, determine which asparagus spears are adequate for harvesting, and grasp and cut these asparagus stalks without damage to the plant.
So the reason why this is an issue is because with asparagus harvesting in Peru, there's a constant labor shortage, which leads to a chain reaction of fewer asparagus harvested, cost increase for consumers, fewer asparagus bought, and then grower has decreased profit, and then grower that can't afford to pay more workers. So going off this, they have the constraints of working within these labor shortages and the field in which asparagus is grown. As far as the scope of work goes, so the divvying up of the tasks, we're going to have UTEC do the overall vehicle design, powertrain and autonomy, mechanical, electrical, and controls, and also the crop collection, while we are responsible for developing the computer vision and the machine learning model, as well as designing the prototype, Cartesian plane mechanism, and also the end effector of the project. The final integration is going to be done between November 30th and December 6th when we're in Peru. And going off this, we've had constant communication with each other, describing constraints of things regarding electrical, mechanical, and controls that we have to abide by.
In researching for this project, we began by researching the current technologies that exist for harvesting asparagus, which included both Cartesian-style robots as well as robotic arm-styled asparagus harvesters. For our model, we went with a Cartesian system and specifically looked into how that can benefit our harvesting capabilities. We looked into different types of end effectors and the pros and cons of each of those different models and ended up going with a two-motor design. We looked into how 3D printing can play a role in the development of the end effector and various connecting components in our system. We researched stepper motors, how those work, and the torque capacities and power outputs for those. We also researched Arduino components and Arduino codes to figure out how that would help us to prototype our system. We also researched the Intel RealSense camera that we'll be using in our system to figure out how it can best be utilized to locate and detect the asparagus. And we also looked into RoboFlow as well. So this is a video showing a demonstration of our project. As you can see, our gripper takes in coordinates, controls the stepper motors to go to a predefined set of coordinates, goes down, first grabs the asparagus, and then follows through with a cutting mechanism to cut it, and brings the asparagus back to its homing starting point for its drop, though this can be changed later and probably will be.
This slide shows a simulated testing setup for the computer vision system, which is using the asparagus spears as the object of interest. The images shows my laptop running the code, the Intel RealSense D435 camera mounted at a certain place, and the asparagus positioned into the clamps. This is likely for consistency during detection and the data capture from the camera. And this setup will help us train or test the vision system under controlled conditions or ideal conditions before moving to real world use. So this asparagus is at 45 centimeter, this is at 40, and this is around 30 centimeter. It's like 10, 20, and 30. Okay. So it's able to detect all of them The middle one is 30 centimeter, like 31.9. The right one is 41.2, and then the very first one is 45.4. This slide shows the output of the asparagus detection system in action. On the left, the YOLO model is identifying the asparagus spears in real time, drawing bounding boxes around each one, with also showing the confidence scores. And on the right, the laptop screen displays the past detection results in JSON format, showing the coordinates of each detected asparagus and dimensions. And eventually, this confirms both the detection accuracy and the system's ability to record structured data for further implementation.
Thank you for listening. We'll have more done in Peru.